Howdy folks, this is most probably the last part of the paper that I wrote and I'd like to discuss with you, which I wrote. By the way, you can find this paper being published at www.academia.edu under my name. And you can find it there. You can Google the name of the paper and then you will come to academia.edu. Oh, by the way, these videos, all these videos, none of my videos are, by the way, according to the COPA law, made for children. It's not that they cannot watch it. I mean, there is no inappropriate things to mention or to sell things to kids and stuff. So people can, children can watch it, but it's not specifically made for them. On the other hand, I think that parents should be responsible for what their children are doing. At least that is in Holland so. I mean, if I would have children and they break a window at the next door neighbors, and the parents are responsible. And that's a law in the Dutch law. Well, according to the COPA, I think that parents are responsible for what their kids are doing, and not other people than the parents. Also including what they're watching. But then again, I have to, according to that new law, apparently, I have to make a statement about that and that these videos, none of my videos, by the way, are specially made for children. So, okay, that's according to their law. Okay, whatever. Okay, that's being said, I will continue. Okay, now, we talked earlier about the whole statistical part, etc., etc., etc. And it is a fact that we discussed over that in general scientists are rejecting all all findings or measurements that fall outside of the 5 to 7s, 5 times to 7 times outside of the times of the standard deviation away from the average of measurements in general. Now, we also saw that some measurements are far away from that average, like 20 to 50 s. So that's scientifically irrelevant anymore. On the other hand, and that's the dishonesty I also like to expose here with scientists in general, they are willing to accept the 20s to 50 or even to 100s results being scientifically correct in other areas. And that area is what I'm going to discuss right here and right now. And I think that is scientifically incorrect, inconsequent, and unscientifically in this situation, which I'm going to talk about in a moment. And so the scientist, you as a scientist, should be very honest. You are willing, you are discarding as outliers higher than 5 or 6s measurements that are higher than that, like 10s or 8s, or you're willing to discard that. But in the next common subject, you are not willing. You are willing to make it scientific, as if it is scientific, realistic, to accept 20 up to 50 or even higher S results, which are is mathematically probable. The mathematical probability is very low, yet you are willing to regard it as a physical reality, and that's not honest. There is a very great dishonesty with respect to the next subject that I'm going to treat, And you may see it already behind me on the board. And I like to address that to the scientific community. If you are scientific accurate and scientifically honest, and you are discarding 5 or 6S and beyond and bigger as scientifically inaccurate, and you're going to treat it as noise, then the next process you also must treat as being noise and scientifically not acceptable. But the majority or a large part of the scientific community accepts this process to be, what I'm going to discuss in a moment, to be true, to be valid, to be scientific accurate, even though it's 20S and beyond 20S. If you look at it statistically, okay. And I don't think it's fair. That's not scientific. That's highly unscientific and therefore highly. I mean, take for example the number of the chances of coins, 1,000 coins, falling all heads up. It has a statistical chance of 10 to the power of minus 301 point something something something. Now, in the majority of scientific findings, this would be discarded as an outlier. But for the next coming up process that I'm going to discuss, it is nonetheless still accepted as scientifically accurate, which is very weird. It does not make sense. Well, in the majority of measurements, you take even 5 or 6S as the limit from which you start to ditch results as outliers. But for this process, you make an exception and you accept 20S to 50S or even higher S's as scientifically correct, which is, sorry, it blows my mind. I cannot take any scientist seriously that is willing to, that normally discards up from starting from 6S and above, but he is willing to accept 20S, 50S, up to 50S, and so on, and beyond that. I'm not willing to take such a scientist seriously, sorry. Okay, what am I talking about? Okay, I'm going to shove the board to the front so that you can see what I'm talking about. Okay, and I'm shifting myself to the side. Okay, I've discussed it earlier in my videos, and I'm going to discuss it once more, but this time with the knowledge, with the videos that I made earlier today, as I think the pen. Okay, now it's all about abiogenesis again, because the scientific community is apparently not willing to listen very well, and in doing so they are very dishonest in my opinion. Okay, so it's in abiogenesis is supposed that amino acids came together and formed proteins, and well, if that is true, then it must meet some scientific criteria. And I've studied this subject, and I've studied the possibilities and the scientific options that these so-called processes are governed by. And in the end, it makes no sense. I'm sorry, it really doesn't make no sense. So I'm going to talk about it some more. Okay. Now, nature can produce in the Urey-Miller style, so in that kind of way, which is accepted by the scientific community as being a valid way of doing. It can produce about 40 different amino acids, and that is investigated by Jeffrey L. Bada in 2013, if I'm correct. he found out that nature can produce in a urine millistine about 40 different amino acids. Okay. Now, 40 different amino acids, that means that nature has a random choice of options of picking one out of the 40 amino acids. That means if you try to calculate it in coin tossing statistics, that means that you have five different coins, and you have to toss them up, and then you get a chance of 1 in 32. So you have to multiply that 32 by 1.25, 1 and a quarter, and then you come at 40, a chance of 1 in 40. So you have 5 coin tossings times 1.25. Yeah, so 2 to the power of 5 coin tossing. So 5 coins, yeah, in one toss. Okay, now so there's 40 chances to pick the correct or the next amino acid, only a type of amino acid, which is, if you compare it to coin tossing, then it's 1.25 times 2 to the power of 5. Now each amino acid has 2 chemical forms. You got a D and L form. You got like lactic acid, for example, in yogurt and in milk and so. There's a D form and an L form. They are chiral brothers of each other. It's like a left hand and a right hand. They look the same, but they are the mirror images of each other. So that's the same with chemicals. There's only one exception, that's glycine. That's true. But for the ease of calculations, I discard that one. All the other amino acids are chemical mirror images of each other. Yeah, except glycine. But for the ease of calculations, I keep that in that part of the 40. Otherwise, I have to calculate with 39 instead of 40. 40 is a little easier to calculate. So for this, but for the argument it doesn't matter because the principle remains the same. Okay, but the D and L form introduces another coin toss. I mean, you have the D form or the L form. So nature can pick in between 2 of them. So it's the coin side, the head side, or the tail side, the D or L side. So that introduces another coin toss. or 2 to the power of 1. Okay. It turns out to be, and that's what he said, organisms all have the L form of amino acids. I think it's the L form. Don't pinpoint me if it's the other way, but all the organisms that trees, plants, bees, horses, dogs, human beings, they all have the L form of the amino acids, which means that nature says, okay, in organism you have all heads up, in all the proteins, in all the amino acids, in all the it's all heads up. It's very important. Yeah, that's why I'm referring to the coin tosses, because nature has the same options in choosing the D or L form. That means that it can choose head up or tail up. Yeah. So that's why I'm comparing it to coin tossing, because in a natural combination of the 2 chemicals, in the racemic mixture of these 2, there's also available left and right 50-50 chance in such a mixture, a racemic mixture. So you can compare it with coin tossing with a fair coin, which is 50-50% chance. That's why I'm referring to the coin tossing. So this aspect of D and L in amino acid forms introduces another coin toss. Yeah? Okay. Now, all organisms have approximately 100,000 different proteins, 100,000 all over the kingdom of animals and plants and fungus and whatever kind of organism. There are about 100,000 different proteins. Okay. The proteins have several tens to maximum about 50,000 amino acids. That means that organisms have proteins that are built up of several tens to tens of thousands of amino acids, and the maximum being about 50,000 amino acids. And all they contain the heads up version or tails up, the L form of amino acids. It's very important. So that means that the proteins contain of an extreme chance. Yeah. Okay. The smallest human protein is about 44 amino acids build up. So that means 44 times head up. Now, each amino acid has two reactive sides, the amino side and the acid side, to bind to bind the next amino acid to. That is already, again, a coin toss. I mean, if you have a strand of amino acid, which is the basis of a protein, then you can react on this side or on this side. So again, you have a coin toss possibility. That's already two coin tosses next to the 40, the chance 1 in 40 chance to pick from. So overall, the first amino acid nature has to start with in formation of a protein has 80 options to pick from. Yeah, the 40 amino acids that nature can produce, or in D form or in L form. So 80 possibilities. The second, until the 50,000th amino acid, has so a chance in being the correct one in 1 in 160. So nature has 160 options to choose from. Yeah? This is all random. I mean, abiogenesis assumes that randomness is the process that governs protein formation when the supposed abiogenesis should have taken place, according to the secular scientists. That means that the options nature can pick from is 0.5 times 160 to the power of n, where n is the number of amino acids. Yeah? That also means that nature per amino acid has 1.25 times 2 to the power of 5 times 2 to the power of 1 times 2 to the power of 1 is 1.25 2 to the power of 7. So one amino acid adding to a protein chain, a starting protein chain, has at least 7 coin tosses, 7. And so 5 and 2. 7 coin tosses in statistical options, yeah, for each amino acid. Remind that. Now, if you take, that means for 100, these are small proteins. The 100 to 1,000 amino acids proteins are relatively small proteins. But they have a chance of 0.5 times 160 to the power of 100. Or basically, you can say it's 1.25 times 2 to the power of 7 to the power of 100. Yeah, which is 1.25 to the power of 100 times 2 to the power of 700. And then only this part is the coin tosses. 2 to the power of 700 is the coin tosses thing. Yeah. Well, all these numbers, you can study them. 1,000 amino acids, it's like this. And that means for 1,000 coin tosses, if you have 1,000 coins, and you throw them all up in the air, and you want to land, or you want to see what happens after landing, this results in a 20 to 50 S result if all heads are up or if all tails are up. Well, now with the amino acids, this far exceeds this 1,000 coin throwing up in the air and expecting them all heads up or all tails up. So it's far beyond the 20 to 50s result that you're going to get. Okay. Now we're speaking here about chemical reactions. Now let's assume that the chemical reaction speed, and this is scientifically fair, about 10 to the power of minus 9 seconds, which is in the most optimal condition that all the chemicals are in close proximity of each other, which in nature is not realistic, because if secular scientists are right in abiogenesis, these amino acids, one is formed on this side of the planet, the other one is formed on this side of the planet, and there's billion and billion of liters or gallons of water separating them. So this reaction speed is only, if it happens at all, spontaneously. That's also a fair question. Does it happen spontaneously? But they are separated, they are diluted. So this is only in the optimal condition where the chemicals are in close proximity of each other. Okay. Now, I'm going to discuss two types of reaction speeds. Suppose that you could argue with me and say, listen, hey guy, you can always catalytically speed up the reaction. And you're right. You're absolutely right. But there is a limit. Now, let's crank up the speed enormously. There is in science known the shortest time possible, physically possible, which has physical meaning. That's the Planck time. Now suppose that the chemical reaction don't take 10 to the minus 9 seconds of reaction speed, but take 5.39 times 10 to the power of minus 44 seconds, which is the Planck time, the scientific Planck time. Below that number, if time would be smaller, time loses its physical meaning. That's what we theoretically know by now. Whether that's real, that's another question. But okay, let's assume that the secular scientists are correct in that the Planck time is the shortest time that has physical meaning. Okay. In case if you have 100 amino acid protein, yeah, it would require 0.5 times 160 to the power of 100 times 10 to the power of minus 9 seconds. That's optimal, in optimal condition, that's realistic. Even then, all heads up and all correctly in the correct position for a functional protein, it would require 4.1 times 10 to the power of 194 billions of years to make that happen. Yeah? Okay. Now if I crank the speed up, it would still require me for 100 amino acids, which is a very small protein, by the way. Yeah, it's not one of the biggest, so it's a very small protein. It would require, in the end, which is absurd, but ultimately speeded up to the max, it would take 2.2 times 10 to the power of 160 billions of years, where all the things are met to produce only one single protein with 100 amino acids. If you crank the speed up to the highest maximum rate, which is scientifically unrealistic because chemical reactions will never go that fast. But the secular estimated age of the universe is only 14 to 15 billion years, yeah, and not these large amount of numbers. The Earth, supposedly the life started to form here on Earth, is only 4.5 to 4.6 billions of years in the secular estimated ages. Well, the main conclusion is, folks, if you take all the evidence, all the statistical possibilities, etc., 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 it is scientifically impossible to make proteins out of amino acids according to the secular idea of abiogenesis. Genesis. Whether you take 14 billion years, 40 some billions, or you take 6,000 years in a creationistic model, in both situations it's scientifically impossible. And if you accept it scientifically, that means that you're accepting results that are 20s and beyond. Then you, as a scientist, should be watching in the mirror and ask yourself, am I willing to accept a 20 and beyond as statistically a result, or do you stick to your scientific merits, and do you stick to your scientifically accurate conclusions, in which you discard 5 to 6s and beyond that number? And that's the scientific honesty that science demands from you. Well, this is what I wanted to tell you, folks. Think it over. It's very important. Okay, thanks for watching. Hasta la basta.